not, right? So, but now as per prediction, by using the equation, our predicted value is this one, right? So now the second person, see, first person not admitted, here also not admitted. Second person wrong. Admitted, actually admitted, but this one, right? Now let us put the cross tabulation for this one. So crossed. So now, so this is my predicted values, right? So this is my actual, this is my predicted, right? So now we will see, right? So now, okay, this is what the table we have seen, right? This is what the table we have seen, right? So now admitted. Okay, so this is what a cross tabulation. It is showing the cross tabulation table, right? So okay, out of 273 people not admitted, 244, right? So out of 127, 33 right? So when you find out a percentage, okay, so we can find out the percentage also, column percentage. So how much we will put the column percentage. Okay, very good. So we can say 278, how much divided by 400, we can find out how much, right? Okay, so we can find out, right? So 245 plus 33, 278, right, out of 400, which is 69.5. That is what it is telling, right? That is over that table, right? So now let us go to the another table. Right. So these are all very easy table. The one important table I will come. That is the most important table. Right. This I have explained. Right. So now this is what the most important table. Right. This is what the most important table, variable in the equation. Right. So this I will take a little longer time, but before going there, so right. So this also, by using this one, right? Observed this one. We use in the machine learning language, we use certain words, right? Same table, right? Same table, 245, 95, 28, 33, same table. But I'm using some other words, right? Out of the admission, right? Out of the 127 people really admitted, right? 93, wrongly we said 33, right? So totally 127 people admitted. Out of that, we know that 127 people are admitted, right? So out of that, we are correctly predicted 33 admitted. So 33, that is rightly predicted out of total admitted. So which is equal to 0.26. That is called the sensitivity. What is sensitivity? Right admission divided by total admission. Right. Both positive. Admission, right? 1, right? So what is specificity? Right. So not admitted, total not admitted, right? So totally as per observed 273 not admitted, right? But we are predicted 245, right? 245, right? So 245, right? Out of the total 245 not admitted, rightly predicted, divided by total not admitted. So which is equal to 0.897. That is called a specificity. So this is a specificity. This is a sensitivity, right? This is specificity. This is sensitivity. false positive, right? Positive but false, right? So now, so in the admitted, right, out of this 61, so okay, so 61 out of this 61. So okay, 33 rightly predicted that we have come. So to this one, right? So in the prediction, we have predicted 61 as a prediction, right? Okay, we have predicted, right? So the top is predicted. This is a predicted, this is actual. So we have predicted 61 as admitted, but right is 33. But how much false? 28, right? So positive admitted as per our this one 61, right? How much false? So false positive admission. What is total admission predicted? False positive. So now that is 0.499. That is called false positive. False negative, right? So out of that total predicted 273. So okay, so total here, right? Total not admitted. In the total not admitted, that is what we have predicted. Total not admitted predicted is 33, in which wrong prediction is 94. 94 out of, okay, wrong prediction, false. Both are false, wrong. This is also wrong, this is also wrong. This is both right. Predicted right, right? So admitted predicted right, or not admitted right. This is false. So 94 is false, admitted, not admitted, right? So false divided by 339, that is called false negative, right? How much is right? Okay, that is called accuracy. So 23 to 45, right? 23 278 divided by this one, which is equal to 0.69.5. That is called accuracy. Some words they will be using, right? This is even doctors, everybody, they are using these words: sensitivity, specificity, false positive, false negative, right? Okay, okay. So now, okay. Now I'm going to explain. Okay, I'm going to explain this table, right? This table is the most important table where you write. Okay, all other things not important. Yeah. Okay, so what are the things we will see? First, we will look at whether we have sufficiently predicted. So by looking at omnibus, okay, so the model is right based on chi-square. We will see what is the how much rightly predicted. 69.5 is the rightly predicted. So okay, so other things, principality, all these things, if you want write, you can write. Otherwise, not necessary, right? So our log like the R square value is this one. So this is what we will report. So these are all, you will write one sentences, you can put everything in one table, you can write. But this table is very, very important. Right? So now you can note down, okay, I'm going to the SPSS, so that is the PowerPoint, and I will explain, right? So now the for rank, this is the beta, right? This is my beta, rank 1, right? So now, okay, you need to remember it is a dummy variable I'm using, right? So this is when how to write. So rank 1 is this much more that we will write, but here we will be using different words. But you have to write based comparing with the rank 4, right? With the reference category. So we already see. So that person is 25 rupees more than this population that we have seen. The same thing. But okay, so we will use the different word. What is that different word? Okay, so first of all, right, one thing you need to know, right? What is that one thing? Right. So first of all, now, so this is the beta. This is the exponential beta, right? E, right, exponential, right? When the beta is 0, when the beta is 0, right? When the beta is 0, my exponential of 0, right? Okay, so now I will write. Okay, so I will start writing. So let us see whether I am writing right. So my, see for example, my beta, right? Okay, so when my beta, okay, right, when my beta is 0, so exponential of beta. So otherwise exponential of 0 is 1. That you need to know. First point, right? Exponential of 0 is 1, right? That is the first point you need to know, right? So that now suppose, all right, now, okay, now my beta is negative. My beta is negative. What does it mean? Right? See, in the regular recursion, beta is negative. What does it mean? Right? When x increases by 1, y will decrease. Y will decrease. That is the negative beta, right? What is negative beta? Please understand. When my x is, what is beta? When there is a 1 unit increase in x, what is the unit increase in y? My beta is negative. My x increases by 1, y will decrease by that extent of beta, right? So that is a negative beta. But here, for example, my beta is negative, right? Negative. So exponential of negative is less than 1. That will be point. That will be point. So now you can see here, right? So here it is negative. So exponential of negative is point, right? So suppose my beta is equal to positive, right? Some positive value. Then exponential of positive value will be equal to greater than 1. So now you can see. Now this is positive value, here greater than 1. Right? So now you have to write it down. My beta is 0. My exponential of 0 is 1. My beta is negative. My exponential of negative will be less than 1. Right? My beta is positive. My exponential of this one is greater than 1. Right? Very good. Yeah. This is 1 point. Okay. This is general, right? It is not here. That is normal. Anybody should know. Anybody should know. That is general. Okay. If you take by using calculator, if you find out, you will get, right? That is number 1. Okay. So now I hope that you have, okay. So now I hope you might have understood this point, right? So now this is, now I'm going to tell important point here, that other things not necessary. This now whatever I'm going to tell, that is very important, right? So now, right? Now, when my beta, see, now one more thing I will write, right? So now, if I say 5 into 2, which is equal to 10, right? Now what I can say, 10 is, right? Since I've used multiplication, what is the word I'm using? 10 is 2 times of 5. Can I say like that? 10 is, Nandini madam, am I right?
Yes, sir.
Right. See, I've used multiplication, madam. Since I am using multiplication, what word I am using, please understand.
Okay, sir.
10 is 2 times of 5. Right? 2 times of 5. Right. Okay. So now, right. See, for example, this one, right? Suppose, right? Okay. So now, okay. So my, for example, right? If it is one more thing, right? If this is 5 into 0.9, what will happen? This will be 4.5. Yes or no, madam? Hello, madam. Yes or no?
Sir.
Yes, when it is not simply okay. So this is
Point is not visible.
point, right? So this is okay. So
Going.
all right. So now this is okay.
Okay.
4.5 is 5 into zero point 0.9 times of 5. Yes or no?
Yes, sir.
So now when I put a point, right, times, now you have understood times, right? So, okay. Now, when my this times value is 2, that is more than 1, this is increasing, right? When it is less than 1, this is decreasing. Right.
Yes,
suppose, right. So suppose let me put 5 into 1.1. This is what will happen. So this is equal to 5.5. So now this is a plus. Okay, this will increase. This is a minus. This is decreasing.
Yes, sir.
Right? Yes or no, madam?
Yes,
so
sir.
when I use multiplication, I should use the word times. Am I right, madam?
Yes, sir.
Yeah. Now, see, please understand. When my beta is negative, right? When my beta is negative, this value should come down, right? Yes or no? When this increases, this should come down, right? Right? So, but when it is negative, my exponential beta will be less than 1 point. Yes or no? When it is negative, these are all points, right? So now, see, when my beta is negative, this will be in point, right? So my value should come down. When my value will come down? Only when I multiply, right? This value will come down. Am I right?
Yes, sir.
Right? So when I multiply with these values, right? So that will come down, right? Yes or no? Yes, it is not one increase, this increase. No. It is now I have to tell, right? So what I have to tell? So for example, if it is 1.5, right? So my odds, this is odds, right? So my odds will increase by 1.5 times, right? Yes or no?
Yes, sir.
Multiplication, right? Only when I multiply, this will come down. When it is positive, when I multiply, this will go up. So when I use multiplication, I said this is okay, 2 times of, right? When I multiply, we will use the term 2 times, right? So now, okay, so we whenever to interpreting this one, we have to use the word times. Okay, so only for that I've explained this much.
Okay.
Okay, we should use the word times, yeah, symbol, right? So now this is arts, right? This is art. Now how I should write is, right? That's all, right? I should write, okay. So now that tells us, right, the first value, right? What is the first value? 5.4, right? For rank 1, 5.4. This is dummy variable, right? How to interpret? By comparing with the reference category, we should write, right? By comparing with the reference category, I should write. I should use the word times. This is odds ratio, right? So all these things you know. Now let me write. So this is 5.4. This is for rank 1, right? How I am writing. So only this sentence is important, right? So that tells that model predicts the odds of getting admission, right? My dependent variable is odds, right? Please remember my dependent variable is p divided by 1 plus p, right? 1 minus p. So that is the odds, right? Okay. So here also the exponential of beta. Now see that you should not forget this equation, first equation, right? Right. So now this equation, right? So odds equal to, this is odds equal to e to the power. So now I am explaining with e to the power x, right? I am using that e2. So this is equal to odds, right? Okay. So now how I am writing, right? Right. So it tells that odds of getting my dependent variable increase 5.4 times. Okay, higher than rank 4, right? Comparison with the rank 4, right? Clear?
Yes, sir.
Right. Yes. So what we have to tell. So now by looking at this one, this is the interpretation. Yeah, we have to interpret with this one, right? How to write. So now my dependent variable odds. So now it is a category variable. So my odds of getting admission will increase 5.4 times, right? So for rank 1 when compared to rank 4. So the probability of or the odds of getting increase, odds of getting admission will increase 5.4 times, right? More, okay, than rank 4. Okay, for rank 1, people who have studied in a rank 1 institution, right? So people who have studied in rank 1 institution, their odds of getting admission is 5.4 times more than the people who have studied in rank 4 institution. Okay, so that is what you need to know. That is the most important, right? So now if you understood and all matter is over, all okay. So okay, you have to use the times, my dependent variable odds, right? It is a reference based on reference category, this many times more, right? So if it is minus, that many times less, that many times less, automatically it will be lesser 0.9, right? Okay, so now, okay, so, okay, some more thing I'm going to explain. Okay, some more thing I'm going to explain. Okay, now, okay, so same thing, okay, whatever it is there, okay, in this, it is taken. So I don't think no book explains this way, so listen carefully. So I've calculated and I am explaining, right? So now all these values I have taken here, 5.4, 1.2. So please, okay, so whatever I'm taking, I've taken from these values. So bold, all these things, right? Okay, so don't think the how SAR has taken now. So this is okay, so this is whatever available beta, right? Okay. Whatever available beta, right? So now what is my equation? My equation is, okay, y equal to a plus bx, right? What is a? Minus 1.52. This is a constant a, right? So this is my beta for rank 1 institution, right? So for rank 2 institution, this is my a, this is my beta for rank 2. So for rank 3 institution, this is a, okay, so constant is a, this is the beta, right? Okay. So now, right. So now e to the power, see now a plus bx. Okay, what is a? This is same. Bx is your constant, bx is 0, right? So for a rank 1 institution, a is rank 1 institution, R1 is a, that is minus 1.522 plus beta 1.687 into 1. Because for that variable rank 1, okay, we might have put 1 for rank 1 institution, all other 0, so 1. So minus 1.522 plus 1.678 into 1, which is equal to 0.165 that I have written. For rank 2 institution, A is same, minus 1 point this one, then beta into 1. For beta, the rank 2 institution, 1, right? So rank 3 institution, like that, I should have written, then okay, so I might have got this 2, I written, right? For rank 4 institution, we might have put 0, that is why this one, right? Very good, not necessary. Okay, so now this is over. Next is, this is also I am calculated, this I have calculated. Now e to the power, this one, right? So e of this is my e of a plus bx. So let me now a plus bx value I have, substitute e of this one, then I am getting this value. E of this one is this value, right? So that, okay, so that I explained in the next one, right? So now R1 is, it is written here, R1 is 0.165, e to the power 0.165 is 1.1793, R2 is e to the power 0.5 minus point. So when it is minus, this will be less than 1, so it is there, right? 1 over, right? Now, all right. So now this is my, okay, e to the power, right? So e to the power means odds, right? So probability divided by 1 plus 1 minus power, that is the, whenever you put e to the power, that is the odds, right? So now this is my odds, right? Odds. Now, what is the probability? Okay, so what is the probability that I will demonstrate? Then, okay, so I will come back to this. Okay. So now remember this one, right? My probability is, right, r divided by 1 plus r. Okay, e to the power a plus bx divided by 1 plus e to the power a plus ex, right? So now, okay, we have already found e to the power a plus bx, all we have, right? So all we have, right? So now we have, okay, all. So this is the e to the power, right? So now I'm going to find out the probability of getting admission who have studied in this institution. So e to the power a plus bx, that is the odds, divided by 1 minus 1.179 divided by 1 plus odd. So which is equal to 2.179, which is equal to 0.541. That is calculated. So the probability of getting admission who have studied in R1 is 0.54. Like the same, second one, so 0.557 divided by 1.57557, which is equal to 3. So like that, okay, done. Okay, 0.5% divided by 1.5. So this one, right? So this is the probability, right? Note down the probability. 54, 35, 23. Okay, so this is 70, right? Right. Okay. So now we have calculated, right? We have calculated what is the probability of getting admission, right? Okay, now we will verify probability of getting admission. We will verify, right? Okay, so this I'm going to verify. Other things I will come later. Other things I will come later. Only 2 more points. Huh? Descriptive statistics, cross tabulation, right? Admitted in the row, you put admitted into the row, right? So the rank into the 4, right? We'll put the column percentage, right? Column percentage, right? Cells, column percentage, right? Rank 1. So, so now this is 16. Okay, so admitted, right? So here is mission rank 1, right? 45.9, 54.1, right? So I should get 49.1. Here it will say PGR, right? Percentage within rank only. Okay, so percentage within. So 54. Okay, so rank. I'll go through. I'll go through. So this is the output. Okay, so I should see. Okay, so rank 1. Percentage. So say within rank. Okay, sorry. Percentage. Okay, so now you can see, right? So admitted rank 1 institution, right? My screen is visible. Hello?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Yeah. Now what I have done is, okay, let me perform again so that you will see, right? So now analyze, cross descriptive statistics, cross tabulation, rank in the row, right? And admit, that is our dependent variable, right, into the column, right? Then cells, row percentage. First I put column percentage, that is row percentage. Now you can see the important thing, right? So admitted, what is the percentage of rightly admitted? 54.1. Yes or no? Percentage of right admitted,
Yes, sir.
right, from the rank institution. From the rank, people who have studied in the rank institution, what is the probable percentage? 54.1. So can we say the probability is 54.1%? Yes or no?
Yes, sir.
Yes or no? See, for the rank institution 35, rank 3 is 23, rank 17. Now let us look at this, our whatever we have calculated, right? So whatever we have calculated is, right? See, 54. All right, percentage of probability 54, 35, 23, 17. Right. So we can find out what is the probability of the people who have studied from the rank 1 institution. The probability of getting admission is 54. What is the, how you calculate the probability? Odd divided by 1 plus odd, right? So this is what I have demonstrated there. This is what I have demonstrated here. I have written here, right? So now I have calculated here. Now by looking at the actual data also I have demonstrated, right? So this is over, right? This is over. Now finally, right? Finally, see, I said what based on this one, I said earlier, based on the E exponential beta of 5.4, 2.5, right? Okay, so this is 5.4, what I said. So people who have studied in rank 1 is 5.4 times more than people who have studied in this one, right? That is what the probability of those people. Now look at here. Look at it. So now see, this is the odds. So what is the, we said the odds is 5.4 times more, right? So what is the odds of rank 1 institution? 1.17, right? E to the power ax is the odd. So the odd of rank 1 institution is 1.17. Rank of, okay, so odds of the, okay, when beta is 0, it is 0.218. So 1.179 divided by, this is the rank 1. The odds okay, e to the power odds of rank 1 institution is this one. So we are, what is the rank 4 institution? Alpha, right? The constant value will capture the rank 4 institution. So this is the constant value 21. So 1.17 divided by 0.218, which is equal to 5.4. So I can tell, right? So whenever the 10, right? What I am doing? 10 divided by 2, right? 10 divided by 2, which is equal to 5. So which means this is 5 times more than this one, right? See, what is this one, right? I will write. So when the value is 10, right? You know, but then I should be happy, right? That is right. So now 10 divided by 2, right? Which is equal to 5. So I can say, so 10 is 5 times of 2. 10 is 5 times of 2. So now the odds of, okay, so this is odds of, right, rank 1 institution is 5.4 times more than the odds of rank 4 institution, right? So first top is rank 1 divided by rank 4, which is equal to 5.4. This is what here. Now we can see here. So this is the output, 5.4, right? So this is the calculated, right? So, right, this is the output, okay? So now this is the calculated value. Now here also we will calculate for this one. So rank 1 and rank 2 institution, what is the rank 2 institution? Okay, odds is 0.557 divided by 0.218. So 0.557 divided by 0.218, which is equal to 2.4. This is what calculated. This is the calculated value. This is the output value, whatever seen in the output, right? So that is why, right, we say 5.4 times. All right. So same result, we have used the word times. Now we are demonstrating time by using the time itself. Right. So this is the, okay. So this is the, okay. This is the, okay. So this is the output. This is the most important output, how to interpret, right? So now, okay. So, right. So this we have done. After that, we will not tell. So now finally, let us take all the values, right? Like that, you can calculate everything and, okay. So sorry. Analyze, regression, binary logistic regression. Let us put all, right? Remaining also. So we'll put, okay, so how to run with all. Okay, so all, right, this is the category variable, right? We'll go here, specify it is a rank, right? So now, okay, so always by exponential beta only you have to use the word times, right? If it is a category variable, okay, you should say the odds of, okay, odds of getting admission, dependent variable. So that is this many times more than this one, right? That is the word you have to use when it is a categorical variable. When it is a metric variable, right? When it is a metric variable, you have to write times only, but not comparison with the reference category. Now, when there is a 1 unit increase in, that, okay, that score, right? So I will tell. So all other things you can see here, you can, how, okay, let us see, right, dummy variables, right? Whether, so if you have noted down my earlier, right? So now 41 degrees, right? Earlier, okay. So if you see the earlier log likelihood, right? What is the log likelihood? So 41 minus, so it will come down, right? It will come down 458, right? if earlier, right? For earlier, let us see the earlier log line. $474, right? 474. If you reduce that value, you will get reduce, right? Reduce. Okay. So now here, okay. So now 71%. Okay. Whether it is significant or not, right? We will look at the reduction is significant. Okay. Pi square reduced by 41, significantly reduced. My R square might have improved, right? R square improved, okay, to, okay, point, earlier 0.6 something, it has improved, okay. So my accuracy is 71%, right? So right to right, okay, so specificity, all you can write, okay, so you can write. Now variable in the institution, right? So now I have to tell when compared to rank 4 institution, see the probability of getting admission, right? So it is 4 point, this not probability, odds will improve, odds, right? My dependent variable is R, we are using exponential, right? So odds will improve by 4.71 times when compared to rank 4, right? So this you know. Now what you have to write here? So my odds, this is also plus, right? This is also plus, this is also plus. So when there is a 1 unit increase in the GRE score, right? GRE score, my odds will improve 1.002 times, right? So this one is when my cumulative cut percentage, when it increases by 1. So this will improve, the odds will improve, odds of getting admission will improve 2.235 times. Okay, so you can find out if you want to find out the percentage, you can find out. So e to the power, right? This is a constant, e to the power a plus bx, right? So you will get e to the power, right? So divided by 1 plus e to the power, then you will get that, okay, probability. So probability getting admission. So but you can, okay, you can find out by using the this percent row percentage also. So this is with respect to the binary logistic regression. Any doubt? Any doubt? This is very interesting. Hello, any doubt?
Anybody have any doubt, please raise your hand.
Hello, madam. Nandri, madam.
Sir, I am here, sir.
Okay, so can you able to understand something, madam?
Yes, sir.
No, voice is very, very feeble. Hello?
Yes, sir, I am here, sir.
I'm not able to understand that?
I understood, sir.
Yes, madam. So anybody not able to understand anything, if you are not able to understand, you please tell me.
Okay, Dr. Vivek Gupta, sir.
Yes, sir.
Good evening, sir.
Good evening, sir. Good evening, sir.
Good evening, sir. Am I audible, sir?
Yes, audible.
Sir, the today's session is a very very informative and excellent session, but it is a bit technical because of involvement of mathematics and all. So if when we get this material, your PPTs and this thing, then I personally feel that I would be able to. I'll have to have a second look on what you told at the moment. We are getting, but I think that when we get the material, I think that time a second look will give us.
No. Okay, it is not technical, sir. It is not at all technical. See, okay. we have to interpret, right? So all this interpretation is easy. By looking at this one, you can tell, right? See, for example, this is the first output. So our prediction improves, the chi-square is improved by this much, right? Otherwise,
Yes,
log
sir.
likelihood decrease by this level. That's all. So when it is significant, our prediction has improved, okay, significant.
Oh, no.
That's all, matter over.
Yes, sir.
So now when
Yes,
you
sir.
go to the another output, my R square is this much, right? So that is the second
Yes,
one.
sir.
Third one, my prediction accuracy is 71%. Okay. So it is not
Yes,
at all
sir.
required any understanding. Now only here.
It has improved.
No, wait, sir. Now here only two things, right? Only what are the two things? When it is the category metric variable. So
Yes,
normally we will say when there is a 1 unit increase in this one, this will increase by this much. Now we are not telling it that way. Here what we are going to tell, when there is a 1 unit increase in this match, okay.
Yes, sir.
So the odds of getting admission will improve this many times. That's all. That's all, sir.
Yes, sir.
No technical, sir. No technical, right? So now I have demonstrated in a technical way. That is why I said not necessary. The only that one single sentence is sufficient, right?
Yes, sir.
So now why? See, I have proved why we are telling times, right? I have proved how we say the probability. All I have proved. I have proved everything, sir. So now, if it is a categorical variable, we have to tell odds will improve, right? Odds will improve when
Yes,
compared to reference category. That's all.
Yes, sir.
That's all.
Yes, sir. Yes,
So
sir.
this many, the bird is this many times, right?
Times.
Why we use times? Because we have to multiply. Because here here exponential beta will not be minus, right? So because
Yes,
beta, when beta is negative, exponential beta will be in point.
Right.
When beta is positive, my exponential beta will be more than 1, right? Okay.
Yes, sir.
So then only when I multiply only, it will increase. When I multiply only, this will decrease. That is why when we multiply, we use the word times. That is what I have explained.
Yes, sir.
So that I might have taken more words, but in case you have to use the word times.
Times. Yes, sir. Sir, thank you so much, sir. Thank you so much, sir. Thank you, sir.
See, the idea is, see, I've seen, okay, so my scholars and all, they used to refer, I'm not referring much. So they used to tell, they write this times, all these things, right? I know it is a multiplication, that is why it times, right? But the odds, all these things, I was having little this one. When I calculated like this, then I understood it is nothing. Yeah, okay, it is nothing. That is why, okay, if you understand this technical part, then you will realize how it is done, how it is calculated, right? So that is why I am doing, sir. So no book will tell this one, sir. No book will tell.
Next is Gnanachandran.
See, one Vivek Gupta sir is not understanding, others will have serious difficulties. Okay, others, please ask, sir. Yeah.
Gnanachandran, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Hello, sir.
Yes, sir.
Sir, my doubt is that there are some papers in others interpret the beta coefficient and create the equation based on the beta coefficient. But most of the papers describe the based on the odds ratio. Odds ratio is most meaningful, but beta coefficient is need not for interpretation or need
No, sir. No, sir. No. Don't use beta, sir, right? When you use beta, sir, right, my dependent variable is log of odds, sir, right? See, logs itself difficult to understand, right? See, when you use beta, sir, right? Then look at my dependent variable. My dependent variable is ln of odds.
admission.
Yes or no, sir? See here,
Yes,
when I use symbol beta and A, My dependent variable is log of odds, sir, right? So can you understand what is log of odds?
Yes, sir. Yes, I got it. Thank you, sir.
You will not understand, sir. So that is why, okay, so use with the exponential, sir. Yes, sir, no, sir.
Yes, sir. Yes. Thank you, sir. Thank you.
The exponential is nothing but the exponential of beta, simple, that's all, sir. But it will become odds. Yes, anything else? So I thought of completing the cluster and the other things. So, okay, anyhow, already time's up. No doubt, huh?
No doubt, sir.
Shall we stop or let me take up one more technique, madam? Madam?
Sir.
So, shall I take up one more technique or shall we stop?
Okay, sir, you can take.
Hello?
Yes, sir, you can take, sir.
Okay. So now I think, okay, so this we'll stop. Okay. So now, okay, thank you very much for all your patient listening. Okay. So already I've shared all the material to Shivakumar sir. So he will send, okay. So how he is going to send, whether he will put it in, I think, because I've sent, okay, as a different file. For Chi Square, I've sent one mail. ANOVA, I've put a separate mail. Okay, so like that, I put a separate mail. Okay, so then, okay, so Nandini madam, please download each mail separately and create a one folder for it. Right?
Okay, sir.
If you put all, people will be confused.
Okay, sir.
For every mail, download, put it in one folder, Chi Square folder, then ANOVA folder, like that. Then you zip it and send it, right, madam? So if you send all together, save all together, zip it, people will be too much confused.
I can do the same to see.
So which data meant for what? All there will be a confusion.
Sarita madam, yes, ma'am.
Now, any questions you can ask, sir.
Sarita ma'am.
Yes. Good evening, sir.
Good evening, madam.
Thank you for the wonderful session, sir. Is it possible to share your email ID if you have any doubts and further after practicing, whereby we can contact you, sir? Or further FDPB, where we are planning to organize in our college, where we can contact you. Is there anything of that kind, sir?
Yes, madam, yesterday, no, madam, you are, why this much explanation, not necessary, right? Yesterday, whether you have attended, madam?
Yes, sir, I attended.
Yesterday or day before yesterday, I have given, madam, in the open, this one I have given.
Oh.
You are not, I think you are not, okay, so now, so I will tell again, I will write it here, right? Okay. So now.
Yes, sir. Thank you, sir.
So my name is...
but personally, I learned SPSS from you, sir. Rather than from the books, I registered for Udemy also, but I was not able to learn what I have learned from here, actually.
Yes, madam.
Actually, I registered in Udemy also, sir, udemy.com, where I bought a course and did. But then too, I didn't learn much. But all these 10 days, I was able to learn something in spite of my household course and etc. So for that, I need...
My name is Kasilingam, right? KASI. So Shivakumar sir will put SH, not SH. So, okay. So DMS. DMS means Department of Kasilingam, KASI. Okay. So KASI, LINGAM dot, here dot you have DMS at gmail.com. Hello?
Yes, sir.
Yeah. So my mail ID is written. It is visible or not, madam?
Visible, sir. Visible.
Yeah.
Visible, sir.
Rasalingam dot is missing, madam. Okay. So
Dot is missing, sir.
dot I am putting, but it is going away. Dot.
Yes. Green sign.
DMS means Department of Management Studies at gmail.com. Any other thing?
Rohini ma'am, photo session is over.
No, sir, not yet, sir.
Not yet. So okay. So now you can ask any doubt. Okay. So I will take up one or two questions. Anything you can ask.
All participants tomorrow onwards missing our guru.
So now any doubts, sir, whatever the doubt they have, let them ask.
Today is open option, but every day we are mute for all participants. Today, any doubts, please ask me your doubts. Sir is available. No, sir. I think
No doubt,
sir, no.
Anita.
No. Oh my God. Okay, Anita ma'am. Okay. Anita ma'am.
Next,
Anita.
Simran Singh. Sir.
Simran Singh.
Hello.
Yes.
First of all, I would like to thank you so much, sir, because it was really a wonderful session and I have learned so many things with so much fun and I enjoyed it a lot. But sir, actually my question is not from SPSS. It's a little bit of practical question. What if you get, you are not comfortable and you are not happy with a supervisor, like you are feeling that my supervisor is not guiding me a good way and I'm not satisfied. In that condition, what should I do?
No. See, no. The point is very, very simple, madam. Supervisors, they do not know. If they are not guiding you, you are blessed.
How, sir?
Yes. See, what happened, I will tell you. See, when I was making a my Viva presentation, so my Viva was examiner from Kottayam University, director Sri Ranganathan, he was my examiner. So people have asked the questions. So at that time, my guide was started answering. Then the examiner said, so, sir, no, sir, let him answer, sir. Okay. So then I was answering, it was going on. Then after coming out, he has told me, sir, see, you are answering well. If I have allowed your guide to answer, he might have given answer on his own. Then he might have given wrong answer also. Then you have to defend your guide. You cannot tell something different from what guide has stated. So then you will be in a different situation, right? If they are not guiding, it is a blessing in disguise. Okay, whatever you want to do, you can do, right? There are a lot of materials available in the internet. Okay, so you can do wonder. So you can do whatever you want. Okay, so with respect to one idea which I can tell is, so collect review as much as possible, right? Then okay, so put it into some place or some software. Otherwise, find out what are all the variables they have studied, right? From that, you choose some variable for your study. Then based on the relationship, you put a conceptual model. Conceptual model is one independent variable, dependent variable, right? That is the conceptual model. For each variable, put the questionnaire, right? Give that questionnaire to some experts, get them validated, and go for data collection. So probably Sivakumar sir might conduct one NAMOS workshop next time. So you
Sure,
attend that workshop.
Sure, sir, 100%.
Okay, you attend that workshop, all right, because that is more important, more relevant. You attend that workshop, easy. That's all matter over. Very, very easy. Life is very easy, madam.
Anita ma'am, next question.
Yes, sir. Good evening, sir.
Good evening, madam.
Sir,
Yes, ma'am. You proceed your question.
sir, with respect to the questionnaire, that is demographic profile age, sir, you told like you need not to categorize, you just give an open-end question. What is the difference between open-ended and categorize? If I give categorical, if I categorize the age, I can analyze even using the categories, isn't it, sir? Or I should only give open-ended question for age and income. Day one, you told like you just give an open-ended question for age and income.
No, madam. I will not say like that, madam. See, it is up to you. For example, income, right? You have collected in a metric form. But if you feel, okay, people will not give their exact income, okay, but they will be easy to take, you give them, right? Based on that, okay, so no confusion, right? So now, when you given as a categorical variable, right? You can use with another categorical variable as a chi-square. You can use with other metric variable as a ANOVA and other things, right? But if you are used as a metric variable, that is dash, then that is a metric variable, right? If you want, you can convert into categorical variable, right? See, I will tell how to convert, right? So you can convert into categorical variable, okay? You can use, if you want metric variable, use that. If you want categorical variable, use this one, this category, what you have converted. So metric variable can be converted into category, but category variable cannot be converted into metric, not possible. So that is why, if possible, try to collect data in a metric form. So you can use many techniques, the regression, anything you can use only when your data is metric. Okay, it can convert into category also very, very easily without any difficulty, right? So I will tell how it can be converted. Okay, so one data I will take. So now let us take this variable. Now here, okay, age of the employer I have collected as a metric, right? 52, 41, right? So now, see, for example, right now, I find out descending order something. Then, okay, so then what I will do is, so now, see, for example, 26 to 35. Okay.
Excuse me, sir.
Not
So we only, sir, not the main.
Not sure. I will show. Okay, I will show now. (26 to 35, 36 to 45, 46 to 60). Okay, so now, see, for example, I have one variable like this, age. Since you have asked age, I am so now this is a metric variable, what actually is. So now I want to convert to category. Now transform, right? Recode into different variable. Why different variable? Because already sometimes I might record this variable also, right? So if I want that, I can use it. Okay, so let me save as a different variable. So transform, recode into different variable, right? Then, okay, age, what is the variable you want to take? Okay, age, old and new. Okay, here, if the old variable is, okay, if the old variable is, okay, less than or less than greater than also use, you can use. If it is less than, okay, let me put less than, right? So 35, right? Let me put, sorry. Okay. So less than 30, lowest to, sorry, lowest to less than 35. So new category is 1, right? Add, right? Second one, if old is, right, 36 to 45, right? So now my new value is 2, right? Add. If my old value is highest, right? So which means more than 45. Let me put 3 here. Okay. So now if I add here, the value will not come. Okay, because I'm not given new, because I created a new name. So let me give a new name, right? So let me put a re-age, some R-E-H, some new names I have to do. So re-age, change. Okay, then okay will come. Okay, so now you can see here. We can see in this one, new variable is created. Right? So now in the values, right, you write, okay, one is, okay, less than, right, less than 35, right, 2 is, so whatever you want, you can put less than 36, okay, anything, whatever you feel like, okay, 36 to 45. 3 is, okay, more than 45, like that you want to put. So to create, okay, it can be done, right? Can be done. So now you can go, if you go and see, you can see here, okay, so here, like this. Will be here, so you can see here, right? All are there. So this can be converted. Now, suppose, see, for example, yesterday I went to Karikudu University. I was conducting some Vivas examination for one scholar. So, okay, when the mean value for male is less, more, okay, a mean value is less, but female mean value is more. But as you was telling, there is a gender gap. So, mean male is having less. Hey, what is this? The mean value is more, but you are selling lesser. Then she was telling, sir, I used to strongly agree once, sir. Okay, strongly disagree 5, sir. So that is why when the mean value is less, which mean value more, I have to sell less. Right? This you will tell, but the reader may not understand. You convert it, right? See how to convert it. For example, if it is a 5-point scale, right? So 2, 3, 4, like this. Okay, 1, 2. So 5-point scale like this. See, wrongly you have put 1 as, okay. So I have to convert this into right, same variable, not a new. So what I have to do is, transform, recode into same variable, right? That this variable, let me take. So okay, so old new. So old is when it is 1, new variable is 5. And when the old is 2, new is 4. When the old variable is 3, not necessary. When the old is 4, this should be 2. When the variable is 5, this should be 1. Right. So now if we go and see, so now we have put 1, 2, 3, 4, 5. Now you can see 543 like that. You can see 5431. So it will be changed automatically. No, it not. So this can be done. If it is one, you can put any number of variables at one stroke. You can put it. Okay. So now, if you want to have some, for example, missing value, I want to convert missing value as a 0, right? Okay. So now here, so this missing value as a 0, right? So then transform. Okay. So recode into same variable. H. So now this are all, let me remove. Otherwise, it will be done again. Okay. So now here, when it is system missing, right? System missing. So I have to put a new value as 0. When the old value is system missing, now, okay. If you continue, right? If you say okay, so now all the values you can see 0, right? All are 0, right? Right. So like this, you can do any conversion, you can do anything. So if necessary, you can convert to category. If you want that, you can use. That is why, right? So, but converting the age you can put, right? So experience, education, how to convert. So number of years of study you can put. Number of years of study you can put. Then that will be a metric variable. That will be a metric variable. Okay, years of experience, dash. Okay, so like that. Right, madam? Right. Okay, so okay. Madam, understood that?
Yes.
Yes.
Madam?
Sir, I'm here, sir.
Not Nandini, madam. The person who has asked a question.
Okay. Sumita, ma'am.
Okay.
Then, yes. Okay. So, any other query, madam? Two
Yes,
parties
sir.
raised again. Two parties.
Sir, thank you, sir. I understood, sir. The one who asked out, Anita.
Yes,
sir.
yes.
Thank you so much, sir.
Thank you, madam. Thank you. Thank you.
Thank you so much. Thank you.
Sumita, ma'am.
Sir, can you hear me? Sir, can you hear me, sir?
Yes, madam. Yes.
Sir, I have entered my data in Excel sheet, sir. Can I take the Excel sheet into SPSS, download Excel sheet to SPSS? Is it possible,
Yes,
sir?
yes. Here, file. Okay. Input. Okay. Go to Excel. Okay. So, input. Right. Excel file can be imported. Right. By using this one. So, Excel file will come here.
Okay, sir.
Sir, this is time to photo session, sir.
Yes, sir.
Photo session. Photo session, sir.
Oh,
Sir,
Yes.
wait, sir.
sir,
Wait.
one small doubt, sir.
Yes, sir.
Sir, this is Sindhil Kenathan from Hallmark, sir.
Oh,
Good
sir.
evening, sir. Good evening, sir.
Yes, sir. Yes, sir. Yes, sir.
Sir, first of all, I need to thank yourself and the organizers, sir. Definitely, chanceless session, sir. I attended so many sessions, but this is the top class. I learned two things, sir. One is SPSS, and the other one is the way to teach the students. No, really, right? I've taken you as one of the role models, and I've started the way you are doing it for SPSS to my students. I've already started.
Thank you,
Right?
sir. Thank you.
And really, I'm getting a very good response in that manner. So I need to thank you personally and through this forum also. That is one thing, sir. Sir, and one small, it might be a very small doubt also. Sir, regarding the missing data, is there any way that, so I didn't attend that first session, sir, so I don't know whether it was covered or
No problem. Tell, sir. Tell.
See, the thing is, in missing data, there are so many ways to fill the data. For example, is that with the mean, is it possible to fill it? Or any other ways to fill the missing data, sir?
No, sir. See, the idea is, right. So, when you have a missing data, sir, right? So, but missing data should not be there if you want to fill.
Yes, sir.
Then, if it is a metric variable, right? If it is a metric variable, so fill with the mean, sir.
Mean. Okay, sir. Right.
Fill with mean. If it is a ordinal variable, right?
Okay.
Fill with the median. If it is a nominal variable, fill with the mode, sir.
Mode. Okay. Okay, sir. Right. Okay, sir. Because I have heard it, but I don't know. That's what I just wanted to check with you.
Yes, sir. Correct.
Right, sir.
Then your result will not be distracted, sir.
Correct.
So one more thing, sir. See, here. Okay. So now I will go back and I will say, right, transform. Let me do transform again. Transform into same variable, right? So old new, right? So if it is if old one is 0, right? Old one is 0. Old one is no. I am doing something different, sir. Okay. So now when old one is 0, right? Old one is 0. New one is system missing, right?
Yes, sir.
So if you have already 0, now I want to make it as missing, right?
Correct.
Now all will be missing value, sir. All will be missing value, right? All will be missing value. Now, so instead of missing value, right, I want to show this as a, okay, there is a if condition and all you can do, right? If missing value is this one, fill with mean, all you can do. I'm not telling, right? Now here, when I have created a variable view, here also there is a missing, right? So now here if you put see, okay, so already I got values up to 5, right? So I can put okay, if I put here 6, so all missing value it will be
correct. Okay, sir. Right, sir.
All missing value
okay.
Okay, so now so I am not saved that. So that will be filled with that value, sir. That also, or you can put a 6 or 7, 8, which means 3 value, right? So now, for example, if I put a 6, right? Let me put 6. Okay, let me put 6, right? See, okay, only I got values up to 10. Only I got values up to 10. So I got remaining values missing value, right? So this 6 also will be considered. See, only I got value up to 10, right? So remaining value, let me do the frequency analysis. So let me take up this one, right? Let me take up this one. So let me say frequency. Now the 6 also will be considered as missing. See here. So up to 5, this one, 6 also considered as missing. So this is system missing means not filled. Okay, by giving some value that you have put as a missing. That is the use of that missing, sir. But you have to use if condition to fill up this one. Otherwise, you have to go each one and you have to fill some. Hello?
Yes, sir.
Yes. Okay, madam, we will stop. Any other question? Otherwise, we will stop, madam.
ಶಿವಕುಮಾರ್ ಸರ್ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ?
ಶಿವಕುಮಾರ್ ಸರ್, ಪ್ಲೀಸ್ ಅನ್ಮ್ಯೂಟ್ ಸರ್.
ಶಿವಕುಮಾರ್ ಸರ್. Yes,
participants,
sir.
Please, it's time for photo session. Please on your video. We record all. I request all the participants to on your video.
Webcam.
I request all the participants just for 1 minute. With sir, it's a great opportunity.
See, my video is visible, sir.
Yes, sir. Super, sir. Okay, everyone. Thank you very much. Thank you, participants. Second slide is over.
Okay, so Tilaga madam, I could see. Thank you, madam. Thank you.
Okay. In third slide, please on your video. I request everyone, please Just last in 2 minutes we conclude this session. Please on your videos. It's recording.
No.
Just-
If you are not, they are not ready, you need not do, sir. Okay.
No,
If they are willing, you can do, sir. Because
Okay.
it is night time, sir. So some girls will be some girls will be nighties and other things, sir.
Okay. Sorry, sir. And last, fourth one. Okay, over.
No, I am in the office, sir. No problem. Okay.
Okay, ma'am.
No, Nandini madam, I have not seen her. So
Nandini ma'am.
Huh?
Ma'am, sir, Nandini ma'am is ready to join as a research scholar in your university. If you
Sir,
agree, sir.
I personally heartfelt thanks to you, sir. Even I was zero before attending your session. Now I learned something from you, that too SPSS, sir. I would like to join your offline program, sir.
So that will be more riskier. I will make everybody to work. That is the everybody should work, sir. When you come.
Okay, Rohini ma'am, please conclude it. Sorry,
Yes.
Nandini ma'am, out of time.
Yes, sir. Okay. So I request Nandini ma'am to present the vote of thanks. Nandini ma'am, over to you.
Once again, it's a great opportunity for me to render vote of thanks for this 10 days national level faculty development program. Completely successfully, we are done with the 10 days faculty development program. This credit goes to organizers. At the same time, equally, this credit goes to our resource person. I heartfelt thank to Dr. R. Kasilingam sir on behalf of me as well as Sheshadripuram Academy of Business Studies for joining with us, for providing and enriching our knowledge towards SPSS. Thank you so much, sir.
Thank you, madam. Thank you, everybody. Thank you, all people. So through this platform, I met around 500 people. Thank you, Mr. Sivakumar sir. So you have made some more people as friend to me. So see, I feel when you have more and more relationship, that is the asset. So okay, so that opportunity you are given. So not only in India, throughout India, and but also some abroad, some people have come. So you have taken my legacy and this thing too, this thing also. So thank you, Mr. Sivakumar sir. Already I've done 5 days. So you do for Amos and other things, sir, for 5 days or 6 days.
Sir, offline,
No,
sir.
sir. Offline, sir.
Sir, please, offline, sir.
No, offline. Online is very good because offline I have to come and other things. Okay, so offline, online I need not apply for leave and other things, no, madam.
Okay, sir.
Yes,
Okay.
that is the advantage. Any time is not a issue. Time at any time you can do, but if it is online, it is easy. Offline means so more than 3 days I will be under trouble, right? But now we have a vacation time, no issue. Vacation time we can do it.
Okay.
We collect your data. Whenever you free, we ready to.
Okay, sir. Okay.
I also once again thank Shivkumar sir, who is our research coordinator, for organizing such a wonderful program for us. Thank you, sir. I also thank our Professor Jairam sir for supporting in order to conduct this program, and also our HOD Soumya madam, Department of Commerce and Management, and IQC
Thank you, ma'am.
Chaitanya. Thank you, ma'am. Our coordinator, IQC coordinator Chaitanya ma'am, and all my dear colleagues, especially who were in the technical team in order to conduct this kind of, each day's technical support, especially. Thank you, each and everyone who is directly or indirectly supported to organizing this program. And dear participants, dear teachers, one who participated for entire 10 days FDP program. Because of you, we successfully completed 10 days faculty development program. Thank you, one and all.
The Nagalakshmi madam is raising the hand. And,
Okay, sir. This session is over. If anybody want to interact with us, sir, you can stay here. Otherwise, you can leave. Thank you very much.
Okay. Now, my request to all: the success of this program depends upon how many people they use it, or in their guiding and in their writing the paper, right?
sir.
Simply coming and going, it is no use, right? Use it, right? So now one day I was there in the I was there in the Saravana stores.
Recording stopped.
Kumar sir has asked, sir, what is this one, sir? Right, like that people